So this is a quick tour of some ideas about education research, and these ideas might be useful for interpreting literature that you're reading for assignment 1, and bits of this might be useful when you're thinking about your research design for assignment 2. But equally, you probably could ignore a lot of what's in this presentation and still write a good assignment 1 and assignment 2. It's going to be really brief. There is a reading list on the Secondary Science Blackboard site, which is the reading list for stuff to do with research methodology. So any of the general texts that are listed there would have a more in-depth look at some of these issues. The Cohen, Mannion and Morrison textbook is a massive, heavy thing and goes into this in lots of detail. And something like the Bell Introduction to Carrying Out Education Research will have a much more lightweight look at some of these issues. The first thing that I would say is that in physics, when we say power, we mean the rate at which energy is being transferred. It's a very precise definition, and all physicists know what we're talking about. In everyday language, when we use the word power, it means all sorts of different things. Political power, the sort of emotional power of a speech. It sometimes means something a bit like strength or a bit like energy. Some of the language around methodology and methods is a bit like that. So don't get too bogged down in it. It's more about the ideas than about the way in which you use words to describe those ideas. Okay, my first question for you is, what is an experiment? Now, most of you are science teachers, and those of you that are not probably did enough science at school to have a good idea about this, even if you've not done any since then. So what is an experiment? And I'm after, what is an experimental research design? How does that work? What's the simplest possible version? And you might want to be thinking about things like variables here. What's the simplest possible version, and why is this a good design? And if that's easy, then you could ask yourself, why is this hard or perhaps impossible to do in education? So pause the presentation and have a think about this. Jot some notes down if you want. Okay, and I'm thinking that you may well have come up with something along the lines of a simplest possible version of an experiment is where you change one thing, one variable, which in science we'd call the independent variable, and you keep everything else the same apart from one other thing which you're measuring, and we would call that the dependent variable in science. And what you're interested in is, if you keep everything else the same, does changing the independent variable have a consistent effect on the dependent variable? And it's a good research design, because if that happens, if every time you make the thing that you're changing bigger, the thing that you're measuring also gets bigger, then you can conclude that it's a causal effect. You can conclude that the thing that you're changing is causing the change in the thing that you're measuring. Okay, so that's what an experiment is. And it's really difficult to do in education, because trying to keep everything the same is virtually impossible. If you just think about the different classes and children that you teach, they're not all the same, are they? And you can get around that to some extent by having very large groups of children or groups of classes or groups of schools, so that you think that the differences between them kind of all come out in the wash. On average, each of 50 schools is the same as, one group of 50 schools is the same as another group of 50 schools. But even then, that's not always true. And fundamentally, that's at the heart of education research. We can't just carry out experiments And that's why when you're reading literature, you need to be very cautious about what you're reading. The evidence may seem very strong, but it's possible for all sorts of things to creep in that mean that what seems like a very strong result is not really all that strong. And that's why we don't have a recipe for how to teach effectively or a recipe for how to run a school really well. Because there's so many variables, so many different things to take account of, that what works brilliantly in one setting might not work very well in another. Okay, so because you're going to come across at least some of these things in the literature for assignment 1, I'm going to just give you an opportunity to think about different research styles, or some people might call this different research designs. So there's a list there of 8 different research styles, and what I'm going to do is I'm going to go through each one and briefly say what it is. But if you already know, then you can just skip the next slides until you get to one that looks like a Venn diagram. Or if you think that you would prefer to just go and look this up, then go and look at a general education research text, and it will cover most of these. Okay, so here I go. The first one is meta-analysis. So you will come across these when you're reading, I think. A meta-analysis is a statistical way of combining the results from several different studies. And it's really well established in medicine, but it's also used quite widely in psychology and education. And in medicine it works really well, but medicine has very clear outcome measures like dead or not dead. Hopefully perhaps not as dramatic as that, but it's that sort of approach. So it's quite easy to say the studies are very similar to each other and then combine them. The question in education research is, are the studies close enough to each other for it to be valid to combine the results? And quite often the argument might be, well, maybe not. Okay, I think what I would say is where you see a meta-analysis, it is an attempt to bring several studies together to see on average what the effect is, but just because it looks like a strong technique doesn't necessarily mean that there aren't problems underlying it. Next is an RCT, a randomized controlled trial. So this is when you carry out an experiment, but because you can't keep all the variables the same, what you do is you take a large number of children or a large number of classes or a large number of schools, and you split them randomly into 2 groups. One group does one thing, the other group does something else, and because you've randomly split them up, you can make the assumption, if your samples are big enough, if your groups are big enough, you can make the assumption that what differences are there wash out on average. So if you see a change between the group that have done one thing and the group that have done the other, because all the other stuff should be on average all the same, you can make the assumption that the thing that you're seeing in your outcome is caused by, so it's that experiment idea, it's caused by the thing that you changed between one group and the other. What we find in education research is very expensive to do, it's very difficult to do, there aren't many of these, and so there aren't many examples of having done several RCTs on the same thing. You would hope that big RCTs would be giving fairly strong evidence, but again, it does seem to depend a bit, and occasionally where more than one RCT has been carried out on the same kind of area, there seem to not necessarily be consistent results. So again, it's the same thing, don't read too much into it, even though it seems like a big expensive study. A correlation study is where you take a whole load of existing data and you use statistical techniques to look at how one thing changes in relation to another thing changing. For example, you might have lots and lots of data on which school children went to and then what their GCSE grades were like, and then, I don't know, what they were earning at the age of 40. And so you might look for some correlations between the ones that were earning more money and, I don't know, what GCSE grades they got, or what kind of school they went to, or something like that. So you're not changing anything, you're just looking at patterns in existing data. Quasi-experiment, well, that's like an experiment, but without the randomized allocation. So you have two groups, but the way in which the groups are chosen is somehow done for you rather than done by you at random. So a classic example would be some schools that have adopted a new program and some schools that haven't. And they're not randomly assigned. The ones that chose the new program all made the same decision. Now that doesn't mean to say those schools are all the same and the other schools are all different in some way, but it does mean that it compromises the normal experimental design. A lot of research in education is like this because it's really difficult to set things up with randomized allocation. It's much, much easier if there's already an experimental and a control group set up for you. So quasi-experiment, like an experiment, but where the groups are already set up before anybody thinks about doing any research. A survey, some of you might have been rung up and asked some questions over the phone. That's a survey. The national census carried out in the first year of each decade. That's a survey. It's where some data is being collected from the things, about the things that are happening. And there are lots of different ways you could collect the data. It doesn't have to be by a questionnaire. It might be by watching what's happening and ticking stuff off. So traffic surveys, for instance, people stand on bridges and count the number of cars and lorries and things that are going past. So that's a survey. Case study is where you look in detail at what happens in a particular case. So, you know, a school makes some decision, academisation might be an example, so it changes its governance structure, and that might throw up all sorts of issues, and it might be interesting to talk to the various people involved and try to plot what's happened and how some of the decisions were made. So case study can be really interesting if you're going to do something similar, because it gives you a lot of pointers about what potential problems and might occur and where the easy wins are, or the things that turned out to work out well. But equally, that might be a unique case, and you might try and do the same thing and it might work completely differently in a different setting. Action research, so this is really what you're doing for assignment 2. So action research is where a practitioner, in this case a teacher, is investigating their own practice and there's lots of different things that you might be doing, but in some way you're looking at your own practice and trying to evaluate the effect of the things that you're doing. And it might often involve looking at what happens when you change stuff, but it doesn't have to. It could be just looking at what's going on in your existing practice. But for most of you, for assignment 2, you'd be looking at a small change in your teaching and seeing what effect that has. And the last one on the list is ethnography. So the best example of this is there's been a few TV programs of people going off and living with remote tribes in the Amazon for a year and wandering about with not many clothes on and eating mushrooms and going through manhood rituals and all that sort of thing. And the point about it is, if you go and actually live with a remote tribe and do the things that they're doing, eat the same food, hunt in the same way, try to learn their language, that's perhaps the best way of finding out what it's like to be a member of that tribe. Okay, so ethnographic research is about the researcher becoming embedded in, experiencing the thing that they're trying to find out about. And there's a lot of criticism of ethnography because is it just, your opinion about, what your experience was like? Is it really just a biography? There's some argument that if it's done well, then it can be really useful and it can get at some things that no other research style can. You probably won't come across ethnography in your reading, but you might just. Okay, so The point about that is not to have a list of different research styles in your head. It's just that I want to flag up that there's lots of different ways of going about doing research in education, and each of them tends to have strengths and weaknesses. And what you're trying to do really with assignment 1 is identify what those weaknesses are, so that when you're critically examining the research that you're reading, you've got some idea of what you might be looking for as possible weaknesses. And one of the things that you should look for is the scale of the piece of research, because if you use a large scale research style and try and do it on a small scale, it won't work. And this is kind of how those research styles overlap. So the green circle is stuff that works at large scale, and of those things, meta-analysis, randomized controlled trials and correlation studies can only be done if you've got really large scale data. And action research, case study and ethnography can only be done at small scale. You could do it, action research by a group of teachers, by a department maybe, but it can't be bigger than that because it has to be carried out by practitioners. And in the middle, surveys can be large or small. So the national census is huge. A traffic survey is quite a small thing. Quasi-experiment, again, the bigger it is, the more it's likely to be a stronger research design. The smaller it is, the more you run into problems with the groups not being the same as each other. And the Eights and Ariel-Maz exemplar that I've shared with you is a quasi-experiment. And that's a good example where some of the problems there are coming from the fact that it's done at quite a small scale. So it can work, that's not a terrible study, but because it's trying to be experimental and you really need large sample sizes, large data sets for that, when you do it at a small scale, you tend to want to be reading into the results. Well, maybe these things were going on that are just because we didn't have many groups and they were different from each other. Okay, so it is worth thinking about this difference between a quasi-experiment and action research, because particularly for the science trainees, what you're doing for assignment 2 quite often sits a bit uncomfortably on the boundary. And because you're a scientist and therefore experiments are your thing, there's a tendency to stray into quasi-experimental ground. Okay, so the difference here probably is to do with how you think about it rather than how you actually do your research. So if you're running a quasi-experiment, then the thing that's driving that is an attempt to get as close as you can to a good experiment design. And so every decision that you make needs to be aimed at trying to control the differences that you're not interested in, control the control variables or account for them. And that's a real problem, and you won't be able to do it really for assignment 2 because you've got very little control over things. Action research might use some of those same approaches, so that idea that you might be making some measurements before and after a change and that sort of thing. So it might seem a little bit like an experimental approach. But the point here is that the thing that drives action research is not trying to get as close as you can to an experiment. The thing that drives action research is trying to learn as much as you can about your own practice. And so there isn't the same drive to try and make your results kind of objectively valid. And there's much more scope for your opinions and the opinions of so qualitative data, your opinions and the opinions of the participants. Questionnaires or little focus group interviews with the children you're teaching. Yeah, those sorts of things make perfect sense for action research. They don't for quasi-experimental design. Okay, so try to be thinking for assignment 2 about, here I am trying to learn about and improve my own practice, and try and get away from the idea of, here I am as an experimenter trying to do an experiment to find out something about teaching. Okay, action research, it's about you. Okay, and then the other idea that you're almost certainly going to come across when you're reading for assignment 1, so it's worth understanding what this means, is effect size. So the for quantitative studies in education research, the results are often given as an effect size. Okay, so what does that tell you? So the first thing is that for most things that you might measure quantitatively, what you find is that most people are kind of around the middle, and you get some that are you get a higher score and some who get a lower score, and you get a tiny number that have a really high score and a tiny number that have a really low score. So that's a normal distribution. It's the shape of that blue hump there, with most people around the middle. And classically, if you set a test, you'll get some kind of normal-ish distribution of marks around the mean for that test. Okay, so if you did something and it significantly improved, sorry, I shouldn't use that word, if it had if it caused an improvement that was real improvement, then you would expect, if you did the same test again or made the same measurement, that you'd get another normal distribution curve, but that the mean would be better than it was before. And that's that pink hump there. Okay, so the effect size is about how far that mean has moved between the blue hump situation and the pink hump situation. And that might be before and after, or it might be the differences between a control and a treatment group in some way. Okay, but the thing is that you need to have some kind of reference point for that. You know, if I told you that the change in the mean was 15 marks, then you'd be immediately saying, well, 15 out of what? Oh, and I'd say, well, 15 out of 100. And then you'd be saying, well, so if they had 30 before and 45 after, are those good scores? Or are those not very good scores? How much would you have expected them to improve in 3 weeks if you hadn't done anything? So all of those things matter. And in order to try and cut through that, what we do is we say, okay, look at the blue hump there. And there's a dashed line which is marked 1.0 SD, standard deviations. So the standard deviation is a measure of kind of how spread out the marks are around that mean. And if you look at where the mean of the pink hump is, you'll see it's a little bit more than 1 standard deviation away from the mean of the blue hump. All right, so that would, if the mean of the pink hump was on that dotted line, if it was at 1 standard deviation for the blue hump, then the effect size would be 1. As it's written there, the mean of the pink hump is a little bit more than 1 standard deviation away from the mean of the blue hump. So that's a standard deviation of, I don't know, maybe 1.2, 1.3, something like that. And that would be an enormous effect size. So effect size in education, you're talking about how far you've shifted the mean in the research study. And if you'd asked 10 years ago, I would have fairly confidently said, well, 0.2, an effect size of 0.2 is quite small. It's not, you know, if it's fairly easy to do, then yeah, great, but it's not all that dramatic. Effect size of 0.4, yeah, that's a significantly, I'll use that word again, there's a decent change. It's a change that would be noticeable. And if it's kind of more than about 0.6, then it's a big effect size, a really big change. But if you ask me now, I would say, well, it depends a lot on the context. So in particular, it depends on age. So this is an estimate of how much achievement of a group of children changes as they get older. So obviously, as children get older, if you give them, you know, a test and then another test on a similar thing, you'd expect them to do better as they get older. So if you were looking just at how much they improved as a result just of ordinary teaching over a year, and obviously getting older and their brain growing and all that sort of stuff, then in an average year, an average 6-year-old improves by sort of 1.5 standard deviations. So that's the left-hand end. Whereas by the time they're 16, a year of just normal improvement is only worth 0.2 of a standard deviation. And if you think about it, when you're 6, the difference between being 6 and 7 is massive, whereas the difference between being 16 and 17 is much smaller. It's a much smaller increase in your age. And so immediately an effect size of 0.2 looks really big for 16-year-olds, and it looks really small for 6-year-olds. So there's a massive issue there that wasn't really known until really quite recently. But also there's a whole load of other things that tend to increase effect sizes, and you'll see quite big effect sizes quoted in education literature, and often they're really not like that. So there's a list there of things that tend to produce big effect sizes just on their own, just as a result of research design. So one is a small sample size, small number of participants. That tends to produce big effect sizes. The second one, a more homogeneous group of subjects. So if the participants in the study are quite similar to each other, that tends to make the effect size bigger. So if they're all grammar school kids, then the spread of achievement levels will be smaller than it will be in a comprehensive, so you get a bigger effect size. If the thing that you're measuring is designed for the intervention, for the study, you get a bigger effect size. So things like, does it affect GCSEs? Does it affect Key Stage 2 SATs? Yeah, those are standardized tests that are nothing to do with the research. You tend to get small effect sizes on those, whereas if you've got a test to measure attitudes towards chemistry that's been designed for the study, then that tends to produce bigger effect sizes. There's a thing called the Hawthorne effect that means that any change tends to have an effect, even if in the long term it doesn't make any difference. Just the changing process tends to have an effect. So whenever you're making a change, you tend to get a bigger effect size than would be there after it's bedded in. And research studies tend to be short time scales, so you tend to get bigger effect sizes because of that. And the less rigorous the research design is, then the bigger the effect sizes tend to be. So quasi-experimental stuff tends to produce bigger effect sizes than really good quality RCTs. And if you're interested in that a little bit more, then there's a link there to the CEM, stands for Centre for Educational Measurement, I think. It's an offshoot of Durham University. And that blog entry is about some of these issues.